What if I told you that Starship, SpaceX's upcoming fully reusable rocket, is the most transformative thing to happen in space travel so far? That's certainly a big claim, but I think it's warranted. Starship not only greatly reduces cost to orbit, but it also allows for much larger payloads and faster turnaround time. In this video, I'm going to list some of the biggest ways Starship will provide value over the next few years, starting with the most obvious and delving into the unknown towards the end. Let's start with a quick recap of Starship progress so far. Starship is intended to be a fully and rapidly reusable rocket system where both the first and second stages land propulsively. Well, technically on Earth they won't exactly land, but instead will be caught by gigantic mechanical chopsticks, but that's a story for another video. Starship aims to get around 150 tons to low Earth orbit and eventually reach a launch cost of $1 to $2 million. It has the potential to send dozens of humans to Mars at a time, and maybe even transport hundreds of humans from point to point on Earth someday. If you haven't followed Starship's test campaign so far, here's the TLDW. Suborbital tests of the second stage started with SN8 in December 2020, and the most recent flight was performed by SN15 in May 2021, and was the first to successfully land and remain unexploded. The first orbital flight will use a first stage named B4 and a second stage named S20. Elon swears that the numbers are a coincidence, but the first stage also happens to be 69 meters tall. Nice. This very nice first orbital flight is expected to happen sometimes after the FAA's environmental assessment is complete. It was supposed to be complete on December 31, but the FAA just extended it to February 28, so we can expect the launch no earlier than that date. They say the delay was due to an overwhelming number of responses, and I have absolutely no idea why that may have happened. But that's it for the recap. I may have missed a few important details, so reach out in the comments if you need clarification or more resources, and I'll be happy to respond. I wanted to start by mentioning the most obvious thing that Starship enables: the colonization of Mars. I've talked about this topic already in my video entitled Things We Need to Figure Out Before Sending Humans to Mars, so I recommend checking that out if you need a deeper dive. In general, the overarching goal with Mars colonization is redundancy. There have been several mass extinction events throughout history due to a variety of causes, and if we want to avoid our own extinction, having a human presence on two planets is certainly better than one. There are several concrete reasons this is the case, but I'll save that for a future video. Elon stated that it'll take around 1,000 starships 20 years to create a self-sustaining Mars colony, so this is of course a long-term endeavor on the order of decades. Each Starship is intended to carry over 100 tons from low Earth orbit to Mars, which is, let's say, a lot. And a lot of payload and a lot of colonists will be needed to create that self-sustaining colony. Elon frequently reiterates that Starship, the world's first rapidly and fully reusable rocket, is the fundamental technology needed to make life multiplanetary. One of Elon's other major ventures is a satellite internet constellation known as Starlink. Falcon 9 rockets can deliver around 60 V1 Starlink satellites to low Earth orbit per launch, while Starship could deliver roughly 400 V1 satellites instead. The V1 satellites, however, are being deprecated in favor of V2 satellites, which supposedly allow for greater bandwidth and can only be economically shipped with Starship, according to a leaked internal email from Elon to SpaceX in November 2021. In addition to providing high bandwidth internet to a large portion of humans in rural areas across the world, Starlink satellites likely have quite a bit of multitasking potential. Starlink already announced plans to partner with telecom companies for data backhaul, and it is partnering with Azure to provide cloud computing services, and laser-linked Starlinks communicating directly with end-user terminals makes the satellites uniquely poised to provide services like edge computing and CDNs. Starlink satellites are designed to deorbit after 5 years, and this short lifespan ensures that the network can continuously be upgraded with later generation hardware, and potentially more bells and whistles like cameras and other sensors for imaging Earth and the cosmos. And additional complementary services like GPS could be integrated as well. James Webb Space Telescope has finally launched after 25 years of development and a budget of $10 billion US. JWST is designed to be folded 12 times to fit its launch vehicle, the Ariane 5, which has a fairing with a diameter of 4.5 meters and a length of 16 meters. The actual telescope itself is 14 by 21 meters when fully unfolded. It'll certainly be one of the most impressive feats of human engineering. Starship will have a fairing with a diameter of 9 meters and a height of 18 meters, which means it could launch JWST-sized telescopes in the future, and the hull of the ship itself could very well be made into the body of a telescope. Additionally, the rapid launch and reuse of the system means that scientists could likely design modular telescopes that are combined in orbit using multiple starships. One of the main reasons space telescopes are so challenging is that angular resolution, or the ability to resolve distant objects, is limited by the overall diameter of the aperture. Starship will hopefully lower this barrier to entry and enable a new generation of space telescopes, which can study our universe in unprecedented and increasingly more beneficial ways. There are a number of existing and future startups that could benefit substantially from both the larger payload sizes and lower cost per ton offered by Starship. Easier access to Earth imaging satellites could enable scientists to fight climate change by identifying significant sources of greenhouse gases like methane, and better model weather patterns and predict extreme weather events. This can certainly be accomplished with existing rocketry, but Starship intends to reduce the cost to space by orders of magnitude, so funding these important ventures becomes more and more realistic. In addition to imagery, easier access to space opens the door for all sorts of manufacturing use cases in low Earth orbit, including but not limited to the following: 3D printed organs, exotic versions of fibers for high-speed internet, carbon nanotubes, superconductors, hydroponic plants, diamonds for high-precision machinery, novel drugs and medicine, and the list goes on and on. If you're interested in some more examples, I recommend checking out factoriesinspace.com, which lists all of the use cases I mentioned and more. One other exciting thing that Starship enables is the launch of significant amounts of payload to objects beyond Mars, particularly the moons of Jupiter and Saturn. We could send deep-sea vehicles to Europa, one of Jupiter's moons, which is hypothesized to have partially liquid oceans of water 100 kilometers thick, which makes it a possible candidate for the discovery of life forms beyond Earth. There are many other exciting worlds that could be explored more thoroughly, like another Galilean moon, Io, which has active volcano plumes and flowing lava on the surface. In addition to landing on planets and moons, Starship could enable research missions to nearby asteroids, with potential for early attempts at asteroid mining. Additionally, more payload to orbit means heavier payloads for asteroid redirection missions like the recent DART mission. Having a planetary defense system in place will be essential for a long-term ability to protect Earth from potentially catastrophic asteroid impacts. If you want a good laugh, I recommend a recent Netflix movie called Don't Look Up, which satirically explores how society might react to an impending extinction-level asteroid impact. Currently, there are only 2 space stations in operation, the International Space Station and the Tiangong Space Station, but there are a number of exciting proposals for new space stations as well. Axiom Space is planning to begin creating the Axiom Orbital Segment, which will begin as additional components on the ISS, with the option of detaching later and forming its own independent space station. Axiom will begin sending their own astronauts to the ISS starting next year, and it will be exciting to see where that company goes in the future. Blue Origin has also discussed plans to build their own space station, dubbed the Orbital Reef, but any work towards that station will either require achieving orbital flight or hitching a ride on Starship. I think the latter is highly unlikely, but I'm not ruling it out completely. Beyond more immediate plans, it's fun to speculate further into the future and imagine ways that Starship could finally enable the creation of rotating habitats. These rotating habitats would use centripetal force to create artificial gravity, which may make the barrier to permanent space habitation much lower. Microgravity has a number of adverse effects on the human body, and preserving muscle tissue requires extensive amounts of exercise. There are a couple likely reasons we've yet to see rotating habitats, and the most obvious is that these structures have to be sufficiently large to create artificial gravity without side effects. Studies have shown that a rotational radius of less than 100 meters can cause motion sickness, and generally a 500-meter radius is required for comfortable Earth gravity. One iterative step in that direction, however, could be to try to simulate moon gravity or Mars gravity, which could allow scientists to observe lower gravity's potential health effects and better prepare us for long-term colonization. There's an excellent blog article by Casey Handmer that discusses this problem in depth and offers a potential solution for creating a rotating station out of a ring of starships. I recommend you check it out. I've added a link under the like button. Starship is still largely unproven, but if things go according to plan, this could catapult us into a new age of space exploration and industry. Fingers are crossed for the orbital campaign next year. That's it for this video. Please subscribe if you find topics like this interesting, and let me know in the comments if you have any concerns or feedback. I'll see you in the next one.